Hi and welcome to this section where we are going to look at the Newton's backward interpolation formula. So for purposes of saving time, I simply wrote down the formula here, and what we have here is a polynomial of degree x. Okay, no, sorry, not a polynomial of degree x. We have a polynomial of degree n. Okay, which we can use to evaluate the function f of x. Okay, and it is given by f of n, that is f at the point xn. F of n is going to be f evaluated at the point xn. Okay, and then plus this is r, okay, which we are going to define shortly, times the backward difference, okay, at f equals to xn, and then r into r plus 1 over 2 second forward difference at x equals to n, that is here, and then plus the usual as it follows, r into r plus 1 into r plus 2. Please notice the difference between this and the backward difference formula earlier on. I think you can see for the backward difference formula it is very similar. It's just that instead of here the signs change. Okay, the signs are the only things which are changing. Here we have a plus, and these are pluses for the backward difference formula, but the rest is the same. The r, which I've said that we should define shortly, is defined the same way. Okay, please note that if we are going to use forward differences, okay, like in the previous videos, if you have realized, you would have realized that the forward differences, the first forward differences, which are evaluated at x equals to x naught, would simply be these values here, these leading values. Okay, these are the leading differences. They call them the leading differences. However, now the opposite is going to occur. If we are looking at these backward differences, we are going to look at these values here. Okay, this will be the backward, the first backward difference. Okay, and then this would be the second, and then this would be the third, and if we need to use this, which is already 0, that will be the fourth. Okay, at the point xn, depending. So let's see, we have for the following values. Okay, we'd like to estimate f of 7.5 using Newton's backward difference formula. So we have our x naught, we have our x1, x2, x3, x4, x5, x6, and x7, which is in our formula xn. Okay, and so what do we do here? We have I didn't leave space for this here. So we would have to get our n. Okay, not our n. We would have to say here, we would set our values for xn. Okay, so in here we see that our xn is what is xn? Xn here is the point x equals to 8. Xn is 8.0. Okay, so our x value is 7.5. We want to determine f of x, where x is 7.5. r, okay, is x minus xn over h. Please remember, for the backward difference here, how did we get our r? We said r was x minus x naught divided by h. But here we have x minus xn divided by h. What is our x? Our x is 7.5. Then our xn is that divided by h. H is uniform, it is 1. Okay, so we divide this by 1 and we get negative 0.5. So what else do we need here? We have r, we have xn, so just the backward differences here. We shall need, if we look into our formula here, sorry, I think I need to look for a better color because I keep on I can't see my my stylus here. Okay, we have f of n. This is the point f at x equals to 8, because we say that xn is 8. So do we have that? Yes, we have that. This is 512 here. Okay, so we have f of n is 512. Then we have the first backward difference, it is 169. Then we have the second backward difference is 42. We have the third backward difference is 6. We don't need the fourth because it is 0. Everything will go to 0. So when we come back here, okay, we have this is given to us. We know r, we know this first backward difference, we know r, we know this is a 2, we know the second, we know everything in here, and then we know that if we wanted to go up to the fourth one is 0, so we are simply using this 1, 2, 3 and 4, and the rest is just substituting like we have done in the previous examples. Okay, for the backward differences, so we substitute and we should be able to get the solutions which is in the textbook here. So the rest is going to be a substitution. I hope you can be able to do it. In case you have any difficulty, you can please just put it in the comment section. Okay, yeah, so thank you, and then in the next video we shall now start our study of the Lagrangian interpolation. Thank you and see you in the next video.